Are you ready for the stellar AstroCruze? You want the volume down a bit? Is that what you All right. Those of you that one of my groupies was yelling out something already. Those of you that haven't met me, I have a checkered past, longtime instructor at the University of Toronto for 35 years, worked at a dark sky preserve showing people the sky through a couple of telescopes, do some TV work in Canada, and author of the book Ultimate Guided Tour of the Universe, and Holland was nice enough to give me a job. Isn't that great? I have big news. I got a couple of books coming up because some people were asking me about my books. I actually co-authored a book with ChatGPT Artificial Intelligence. I named her Zoe Cosmobot, okay? I thought that was a pretty cool name. This one's kind of more of a university textbook kind of level, but the second book is this coffee table picture book, which will be out soon. Not quite yet. I'll give you more details on the last event. Called MULTIWAVELENGTH ASTRONOMY, a superhuman view of the cosmos, just loaded with pictures, a lot of the pictures that I've been showing you at these talks. Okay, so here we are. We're making our way along. We are here on event number 4, the stunning view from planet Earth. And don't forget to come back in 3 days for expedition to the bizarre and extreme cosmos, where we are going hunting for black holes. So that should be fun. Tell you a little bit about myself. Don't forget, I love to support rescue shelters in Canada, and here is my rescue dog, Katie. Okay, isn't that cute? Look what her mother puts her through in the winter in Canada. Okay, I also love to ride around on my Ducati motorcycle, and I have even been known to ride around on in my tuxedo, okay, in my younger days. And my favorite Star Trek series of all time has to be the original, right? So not the previous ones. But enough about me. Let's learn more about you. I need to see a show of hands on a few things. Do you own a telescope? Raise your hand. Whoa, I wasn't expecting that. About 30 to 40% of you. Did anyone happen to bring a telescope? No, it's been cloudy most days. On our last cruise, we literally had someone brought a 16-inch telescope with him on the cruise. Have binoculars on this ship somewhere. And by the way, those of you in balconies, I think there's binoculars in the closet. Raise your hand, binoculars. Oh, yes, that's about 80% of you. Wow, wasn't expecting that. Ever worked for any Air Force, any country in the world? Wow, got about 9 people there. Thank you for your service. This is great because, thank you. Because some of the Air Force people on board have been telling me about the weird UFOs they've been seeing. So we got to get to the bottom of this. Ever worked for NASA, ESA, or any other space agency or aeronautics company? Raise your hand. Okay, just a few hands over for this one. And finally, have a working and connected stargazing app on your starphone for looking up to the sky. Whoa, I wasn't expecting that either. About 50, 60% of you. That's great. Okay, let's get into today's talk, the stunning view from planet Earth. Now, I was actually up till 3:30 in the morning last night getting ready for today, and I realized at about 3 in the morning I had this brilliant thought that came into my mind that today's talk is actually my absolute favorite out of all 7 talks. Okay, and I think you're going to like it the best because you guys are going to see some beautiful pictures. So here we go. We're going to go up to the atmosphere. We're going to talk about deadly meteorites. We're going to look at some stunning pictures of nebula. We'll spend a lot of time on the moon tonight, and we'll even play a couple of games called Moon Quest and name that nebula so you can be the best person for all those trivia games that are being played on the crow's nest. We're going to start off slow. Let's just start off in the atmosphere with some beautiful lenticular clouds that you can see here, which are backlit from the sun that has already set, but it's still lighting up the lenticular clouds above. Beautiful picture there. And of course, rainbows like these two in Jasper and in Niagara Falls, Canada. And you'll often see these, of course. But what you don't know is that there's many different kinds of rainbows. There's something called a double rainbow, where you kind of see like a second copy of the rainbow. So keep an eye out for these things when you see some rainbows out there. And on moments before the Queen died a couple of years ago, there was actually a double rainbow in the sky that instantly appeared, and some people thought one was for Queen Elizabeth and one was for Prince Philip. So there you go. And some people get really excited about stuff like this. Not me, but some people, like this guy here by the name of Paul Vasquez, who saw for the first time a double rainbow. Watch the volume on this one for me. Here goes.
Oh my God, it's full on double rainbow all the way across the sky. Oh my God. Oh my God. Oh God.
He got a few million views for this.
What does this mean?
What does this mean?
Oh. Oh my God. Oh. Oh.
This is the X-rated version of today's talk.
Bright. Oh my God, it's so bright and vivid. Oh. Oh. Oh.
This goes
So
on and on.
beautiful.
All right. And then there's this thing called a supernumerary rainbow, which is caused by some ice crystals and some stuff going on in the atmosphere. It's almost like you're seeing multiple copies of the rainbow there. These beautiful things called fire rainbows, scientific term called a circumhorizontal arc, just beautiful, caused by ice crystals up in the cirrus clouds. Or how about this one, a polar stratospheric rainbow clouds. No special effects on this. These were the actual colors coming out on these clouds here. Just gorgeous. Oh, moving on to some lightning above the Statue of Liberty, or let's go to Toronto, Canada, where I'm from. We've got our CN Tower there, and you can see all kinds of lightning strikes hitting the top of the CN Tower. Or these intercloud lightning over Toulouse, France. So these aren't reaching the ground, but the lightning is going back and forth between different parts of the clouds. And then we talked about this a couple of days ago, these things called red sprites, which are lightning way, way up in the atmosphere that aren't coming down to planet Earth. They were first spotted by astronauts on the International Space Station, and no one really believed that they were seeing lightning going up that way. But they finally got a picture of it. The scientists started figuring out what caused these things, and we get this beautiful picture above the Aegean Sea in Greece. Something called a sun pillar, kind of like a pillar of light that goes directly above the sun. And here's a sun pillar at sunset. And scientists are figuring out what causes these things. In this case, it's sunlight reflecting off of falling ice crystals, creating this light column directly above the sun. Or if one sun's not enough, you can have three suns with this thing called a sundog, which is also caused by ice crystals. And it looks like you got three suns, but of course, it's just a mirage. You only get one sun per day. Parhelic circles. We got the sun in the middle of this picture and a circular halo, rainbow halo occurring around the sun. We can even get these full moon halos, so halos appearing around the moon. And not only do we get a full moon halo, in this picture we got the full moon halo and a SpaceX Starlink rocket launch right at the same time, just giving a great juxtaposition between those two. Or how about a full moon with a rainbow cloud halo? Beautiful colors there. Okay, a couple of days ago, someone was asking about these green streaks, Bob. I think that was you. And here's an actual picture from San Diego, California. And basically, these green streaks appear at the top of the sun. They only last for a second or two. They occur at sunrise or sunset. They're very rare, so chances are you might not see them. But on the ship, keep your eye out. Right at the last minute, here's another picture of one just as the sun is setting, a 1 or 2 second green flash appearing right above the sun. So what causes these green streaks? Well, we got scientists on board to help us figure this thing out. And of course, it's a mirage caused by atmospheric distortion that occurs when there's a rapid temperature change in height, and light from the sun separates or refracts into its different colors. That's called Rayleigh scattering. And the color green briefly becomes visible to the eye for a second or two, sometimes some bluish colors in there, but rare phenomena, we're starting to learn more about what causes them. Okay, who can tell me what this thing is over here? Sure, the Milky Way galaxy. Who can tell me this thing over here? Yell it out. The Northern Lights. No. Anyone else? What is it? No, not the Southern Lights. This one is Steve. Okay. Now, it's not the Northern or Southern Lights. It was spotted by amateur astronomers in Alberta, so they gave it the nickname Steve, but it's not the Northern or Southern Lights. This occurs much higher in the atmosphere than the Northern Lights. And so NASA heard about this thing, so they got their scientists trying to figure it out. And of course, once they already knew that the Canadian amateur astronomers called it Steve, they made up a name for it. Okay. So now that's what Steve is. And we're still trying to figure out what it is. Some beautiful pictures of Steve in Alberta, Canada. And it's also nicknamed picket fences because sometimes you get this green picket fence look appearing. And this gorgeous picture above Mount Robson in British Columbia of the green picket fences of Steve giving us a beautiful visit here. Okay, who can tell me what this is? Yell it out. Northern Lights. No. Okay, it's a Southern Lights. Okay, how about this one from Norway? Who can tell me what this is? Yell it out. Okay, yeah, we finally got the Northern Lights here. Let me just show you a sequence of some Northern Lights shots. We got another one here from Norway. And when you see these in real life, you won't quite get that much green. These are typically long exposure of 10 or 20 seconds on the camera, so it won't quite look like that. Here's one over Iceland. Another Iceland shot. Greenland. And most of the time these northern lights will be green in color, but based on the charge in the particles and different things occurring, you can actually get other colors like purples and pinks and other things like that showing up in the northern lights. Over Gordon Lake, Saskatchewan in Canada, Labrador, Canada. And a lot of people ask, what causes these things called northern and southern lights? Well, basically what's happening is you've got the Earth here, and you've got the sun every day that's shooting charged particles at planet Earth. And those charged particles are powerful enough to wipe out all life on planet Earth. Luckily, we have a magnetic shield or a magnetic field that's protecting us. And when those charged particles come crashing towards the Earth, they get deflected by the magnetic field up to the North Pole and down to the South Pole, and then they crash down, for example, on the North Pole, and then those charged particles go down across the atmosphere. So because they're hitting the North and the South Poles, that's why you tend to see them further north, not as much in America, but more in Iceland, Greenland, Canada, etc. So that's what causes the northern lights, and you can see a beautiful light show here in this time-lapse video. Okay, this is a shot we actually got when I was up in the Killarney Dark Sky Preserve in Canada, and if you look closely, you can literally see several different gradients of color in the lights coming through. And once again, when you see this live, your eyes can't quite pick up those colors, but the cameras definitely do. And we even got a couple of bonus shooting stars in this picture that we took. Okay, so meteors. Meteors are things that come, asteroids or comets that are crashing through Earth's atmosphere, going 20 times faster than a speeding bullet, heating up to hundreds or thousands of degrees, and that's why you get these streaks. Most of the time, these things burn up in our atmosphere. So they'll come into the atmosphere. They might be the size of, let's say, 2 school buses, but by the time they land on the surface, they might only be the size of a softball or something. Artist's illustration of the Perseid meteor shower. So when you see a meteor shower, they appear that they're coming from a particular location. And this happens in the summertime, but throughout the year, you might have heard of some of these names. At different times of the year, we're going through different patches of dust and dirt from comets from years ago and causing these various meteor showers that are going to occur at different times of the year. This one here is actually a time-lapse video, a beautiful view of a meteor burning up in the atmosphere. And in this case, you can see it streaking through, and then it just vaporizes and disappears. An award-winning photo of the year in 2013, capturing a long exposure image of the Perseid meteor shower. A great 360-degree view of the Perseid meteor shower. You can see all the horizon around the entire horizon, 360 degrees around you. Perseid meteor shower, as well as the Milky Way galaxy right across the center there. Okay, here's a great shot of the Milky Way galaxy at base camp in Nepal. And the average person, when you look up to the sky, even in the darkest of darkest places that you're going to go, the human eye can only see about 3,000 stars or so. But guess what? That Milky Way galaxy contains about 400 billion stars. Okay, and we're just seeing roughly 3,000 of them. A view over Killer Mountain in Pakistan, view of the Milky Way galaxy. Arc of the Galaxy. This is a gorgeous picture from New Mexico. Now, the Milky Way galaxy is kind of like on a flat pizza-shaped plane, and we are inside that flat plane, and we're looking at the side of the Milky Way galaxy. But how is it possible then that the Milky Way is curved like that? Because I just told you it's like a flat pizza shape. So guess what? This image distortion of the curve is caused by the use of a wide-angle lens. What you're actually seeing is the Milky Way galaxy in a straight line from that horizon all the way over to that horizon. So in real life, it's a straight line, but it kind of looks curved in some of the pictures like this that you'll see. Oh, one of my favorites, rainbow aurora. Aurora at the same time. See if you can spot any star patterns in this picture. If you do, please yell it out. What are you seeing? You're seeing the Milky Way. Yes, that's that curve there. That's our 400 billion stars. Anything else? Okay, guess what? Under the S there, we got the Seven Sisters, the Pleiades. Any star patterns inside the colored area? Yell it out. Yeah, you're seeing the Big Dipper, good eye, and the Little Dipper right there. And as a bonus, what else did we get in this picture? I don't see Orion's belt in there. We got the bonus of the Andromeda Galaxy, 1 trillion stars in that little smudge there, or 500 billion to 1 trillion stars, with trillions and trillions of planets or moons, possibly with the possibility of hosting life. Just a gorgeous shot, capturing so many different things from Iceland. Okay, let's zoom in now. You see the Milky Way galaxy across the top there. And in this case, it's interesting because there's a bunch of star formations that aren't in that pizza-shaped plane. They're actually orbiting around the Milky Way galaxy like that. It's these clusters of galaxies. Sorry, not galaxies, but called globular star clusters. And we're zooming past one right there where you can actually take a look. And look at the resolution that the Hubble telescope is getting and how much deeper and deeper into the universe it can get. It just blows my mind every time I see this. And hidden away in this gem of a picture is something called a dwarf spheroidal galaxy there that we can spot because Hubble and James Webb and those telescopes can literally just look so deep to such incredible resolution. The Milky Way galaxy on the left, this picture from Chile, but who knows what that bright spot on the right might be? Yell it out. City lights? No. Okay, so this is something called the zodiacal light, okay? So the planets in our solar system are also orbiting on a flat pizza-shaped plane. And that plane is called the ecliptic plane of the solar system. and that happens to be right along that line there. So a lot of people don't realize this, but the sun, the moon, and all the planets within a few degrees are going to go right across that path. Okay, so it's a different plane than the plane of the Milky Way. And so you get this beautiful triangular shaped glow, and what causes that is in our solar system you've got a bunch of gas and dust particles and things like that, and it's just the sun has set and it's deflecting off some of those dust and gas particles and things like that, causing this glow called the zodiacal light. Okay, then you get these beautiful long exposure images where you can see the directions that the stars take at night. And here, those things are called star trails when you take a long exposure. And who can tell me what that thing is right there? It doesn't seem to be moving like everything else. Of course, that's Polaris, the North Star. Of course, why is that important? Because that's how ancient mariners would know which direction's north and how to get from Hawaii down to Tahiti. You've probably heard some of those stories. Just amazing to be able to know that for thousands of years, ancient mariners used the star patterns, finding the North Pole, etc. Which stars set and rose at certain times would tell them exactly where they were going. Oh, this stunning night sky time lapse, an 8-hour-long exposure on the camera here. This is star trails. And the great thing about this image here, it's actually showing that stars are different colors. So a lot of times you just think to your naked eye that they're all just white. Well, guess what? They're blue, they're red, they're different colors, and that tells us a lot about those stars. So in fact, in the case of bluer stars, they're hotter. In the case of redder stars, they're a little cooler. Okay, and in case you didn't know, Polaris is part of the Little Dipper, and if you were to stare at the sky for 24 hours straight, Polaris, this Little Dipper and the Big Dipper, would orbit once around Polaris, the North Star, in this pattern. So depending on what time of night you look, you're going to see it in different positions. Okay, you ready for a math break? Didn't they tell you about this? No? Okay, so let's go. Now you got to listen to my instructions carefully, otherwise this is not going to work. Okay, you ready? Pick any number from 1 to 10. Actually, between your couple, agree on a number so both of you get the same number. So decide what your number from 1 to 10 is going to be. And I do this to make sure that at least one of you knows how to do math. No, I'm just kidding. Okay, you got your number 1 out of 10. Okay, memorize that number because I'm going to ask you to remember that in just a second. Whatever your number is, I need you to double it. Okay? You with me? Add 2. Okay? Divide it in half. Check with your partner to make sure you got the right number. So you doubled it, added 2, divided in half. Do you both have the same number? Okay. Minus the number you started with. Okay, minus the number you start with. Now add 3. Okay, you all agree on the number? Okay, whatever that number is, please figure out what letter of the alphabet is. So if you had number 6, you would have an F. So figure out what letter of the alphabet you got. And what I need you to do now, this time, don't talk to your partner. Pick any country anywhere in the world that starts with that letter. Don't tell your partner. You can only talk to each other if one of you can't think of a country that starts with that letter, and then you can agree on the one that one of you thought of. Okay, everyone got a country? Raise your hand if you don't have one yet. We can help you. Oh, you're okay. Okay, so you got a country. Whatever number you have, just add 1 to it. Now, whatever that letter is, don't tell your partner this part either. Whatever letter that is, pick any land animal anywhere on planet Earth, not a bird or a fish or anything like that. Any land animal that starts with that letter. Okay, you got it? Okay, whatever that animal is, pick a color for it. You got to picture it in your mind. What does that animal look like? What color is it? You got it? I can't believe you guys all got the wrong answer. Guys, there is no gray elephants in Denmark. Okay? Isn't math fun? Okay, let's explore some deadly meteorites. Start with Oumuamua, this thing that came through our solar system a few years ago. Yeah, give me lower volume, I'll talk over this one. Oumuamua is actually a meteorite, or it could have been a comet, but it didn't have much of a tail, that came through our solar system. And based on its trajectory through our solar system and its speed, it was determined it was not an object from our solar system. This is an interstellar object from another solar system paying us a visit, going through our solar system. You can see its path here. Didn't hit Earth, luckily, cut through, and went on its merry way, but much faster than the things that are floating around in our solar system. Which is how we knew that it was from a different solar system. Now, we got to worry about these things because we don't want any of these things landing on our head, especially if they're this big, because you get any of these meteorites that would hit us like this, huge impact blast ejecta. You would get possible ocean tsunamis all around the world. So it's not the kind of thing you want to do. But guess what? A lot of people don't realize we probably get about 17 of these things every day landing on Earth. Okay, luckily most of Earth is oceans and stuff, so no one really notices most of them. But a decade ago, we had the Chelyabinsk meteor in Russia. This thing came flying through, and it exploded up in the atmosphere. And I don't think even the pieces landed on this one because it was going so fast and it all exploded. And guess what? It caused windows to break all over the place, smashing windows and glass, sending about 1,000 people to the hospital. No deaths, so we were okay on this one. And I actually got a video of how powerful this blast was, even though it blew up, I think it was a couple of kilometers up in the air. Let's take a look. Okay, so people saw the flash of light, they rushed to the window, and then 2 minutes later, the sound blast hit the window and smashed the glass, sending people to go scurrying in their offices and homes. All I can say is, run! Okay, here's one in a warehouse. Pretty potent. Yeah, when you see a flash like that, don't rush to the window. All right, enough death and mayhem. Okay, and then a lot of people don't realize a few years ago, a meteorite actually landed in Toronto, which is where I'm from. Let's take a look.
Yeah. Oh my god, it's so pretty. Okay, look, it's really cool. Take a picture.
Yeah, pose.
Did you take it?
There's the CN Tower back there.
It's on video, hold on.
Oh, wait, look. Oh my god, you see that?
Oh my god.
Oh my god.
Oh my god. Oh my god! Oh, no.
Okay, fine, I had to throw that one in. Photoshop is wonderful. But I have to tell you the story of Michelle Knapp, who bought her very first car in Peekskill, New York, a Chevy Malibu. She bought it for $400. Raise your hand if you remember what your first car was. Okay, how exciting was that, right? She gets her first car, she parks it in the driveway, she's watching TV one night on the couch, and all of a sudden, smash! She goes outside, and yes, a meteorite came down, smashed her beautiful Chevy Malibu, totaling it. Imagine if that happened to your first car, that would be bad. But anyway, don't feel sorry for Michelle because she got $69,000 for the meteorite. And she got $10,000 for the car. True story. These things can be pretty big if you're ever at the American Museum of Natural History in New York. They've got this one here, over 15 tons, the largest one found in the United States. Or this one here in Namibia, the Hobo meteorite, landed about 80,000 years ago and weighs 60 tons. You wouldn't want one of these landing on you. And we have evidence on Earth, like Meteor Crater, Arizona, and Quebec, of where these things have landed in the past. It was harder to find the one in Chicxulub in the Yucatan Peninsula of Mexico. That's actually the one, of course, that landed and killed all of the dinosaurs and 80% of life on Earth. So we'll talk a little bit more about that one. But here's a picture of Meteor Crater in Arizona. There's the visitor center. Just a couple of stats on this one. About 3/4 of a mile across, 600 feet deep. And the meteorite, or the asteroid that caused this, was probably about 150 feet in size, but it blasted out 175 million metric tons of rock. But that isn't the most amazing thing about this picture. The most amazing thing is, and this landed about 50,000 years ago, the most amazing thing about this picture, I can't believe it, it just missed the visitor center. Okay. Okay, then there's the one that landed in Mexico. This is just an artist's illustration because we weren't around 66 million years ago. This is what it might have looked like after the impact. This one here, much bigger, about 6 miles across, and caused this crater of about 93 miles across. Just a huge blast. And how do we know it was 66 million years ago? Because geologists help us out here and scientists. We've got this layer in the sedimentary rock all throughout Earth. And this particular layer is called the KPG boundary. And it happens to be loaded with a mineral called iridium. Now, iridium is not very common on planet Earth, but guess what? A lot of the meteorites that we found that have landed are loaded with iridium. So that's how we know when this blast came out and covered the atmosphere of planet Earth, that this iridium came from that particular one. And when we do radiometric dating, we literally peg it dead on to 66 million years ago. So scientists aren't just guessing this stuff. They're doing the science, measuring things, and being able to tell you the story of when and why the dinosaurs died off, and probably about 80% of all life on planet Earth because of this impact. All I'm saying is now is the time to develop the technology to deflect an asteroid. They didn't quite make it in time. However, NASA has a planetary defense office, and they actually track these things. They track their orbit. They determine which ones might be causing all life on planet Earth to end. And so they're tracking different ones, like this artist's illustration of an asteroid 2023 DW, which is going to land, or getting close to Earth. It's not going to land. February 14th, 2046. This is how far ahead they know these orbits and how accurate they are on it. But this one's going to miss us, so you're okay. But then there's this other one called Apophis in this artist's illustration. Now, Apophis is about 400 yards across, so 4 football fields or so. Doesn't sound like much, right? But it weighs 20 million tons. And if it landed on Earth, it would have the impact of about 65,000 Hiroshima bombs. Okay, so you don't want one of these come crashing onto Earth. When is it going to do the next pass? Friday, April the 13th, 2029. We can't make this stuff up. So Friday the 13th, of course, that's when it's coming, and it might come within 23,000 miles of Earth's surface, inside the orbits of some of our geosynchronous satellites. That's how close this thing's going to come. And NASA's telling us not to worry about it because they've got that trajectory down pat. Guess what? They know when the next pass is going to be as well. April 13, 2036. Really? At least the universe has a sense of humor. Okay, this is an actual video. I want to tell you a little bit about 3 particular meteorites that you're going to be interested in. And this is an actual video of Meteor Crater in Arizona. And you can see how huge that is. And they thought that it was a dormant volcano until several years back. They realized the middle of it was loaded with meteorites and iron and nickel and iridium and things like that. And so they named the meteorites that they found in Meteor Crater, they called them the Canyon Diablo meteorites. And I have a sample just to give you an idea what these things look like. So this is a 16-pound sample, about 98 or 99% solid iron and nickel. Okay, you could attach magnets to it and they'll stick, different than the rocks here on Earth, okay? Or this second one I wanted to tell you about was the Sikhotia-Lin meteor fall in 1947 in Russia. And this particular one, of course, there wasn't cameras back then, so an artist had to paint this streak of the meteor coming down and landing in Russia, and it broke up into thousands or hundreds of pieces that literally got impaled inside trees and different things like that. And this is an example of what that one might look like. This is an 8.9-pound sample from Russia that landed in 1947. The third one I wanted to show you was this Sericopallasite meteorite from Kenya, Africa. And this might have been a much larger piece, but geologists will split it up into thin slices, and then they'll put a coat of urethane around it just to protect it. But the iron and nickel is so strong on this one, we've also got some round magnets that you can see there that are attached to it. Okay, so there's three pieces I wanted to introduce you to, but there's a reason why I wanted to show you these three pieces, because I like these pieces so much I bought them. This one only cost me $10,000 US, by the way. So I bought them and I created something called a meteorite petting zoo. Okay. Now, if you ever want to touch meteorites, go to the museum in Toronto, but unfortunately everything's behind a glass case, so you don't get to touch them because they'll start to disintegrate and stuff like that. But I built this thing called a meteorite petting zoo, and if you're ever in Toronto, come see me because I want to show you my meteorite petting zoo, okay? Oh wait, I think I brought some. Hold on. Oh yeah, look at this. I brought some of my meteorite petting zoo. I brought two of my pieces. The meteor crater was too heavy to bring on the airplane. Believe me, I can barely get this one through customs no matter where I go. They think it's a weapon. So this is the one from Kenya. We don't know when this one landed. This is the one from Russia that landed in 1947. And you can see there we've got the magnets on it that you can play around with, because at the end of today's talk, we're going to take some pictures. Are you in? All right, so please join us at the end for pictures. And what are these things? These things are all about 4.5 billion years old. These are like time capsules to the beginning of the birth of Earth and the beginning of the birth of our solar system. So it's like a time capsule that has just been floating around the solar system until it landed here, and now it's in our hands. So you want to hold a time capsule in your hand that's 4.5 billion years old. Today's going to be your chance. Okay. You ready for a game of Moon Quest? No, come on. Are you ready for a game of Moon Quest? Okay, 10 questions for this game. Look to your partner and please decide who's the smartest person in your family. Go ahead. Okay. No fighting over here. Okay, 10 questions. Get your 10 fingers ready, because this one you have to keep score. So I want to see who's going to win on this particular game. The moon will no longer be orbiting Earth in 3 billion years, and I'm not giving you much time to answer these, so you got to think quick. The moon will no longer be orbiting Earth in 3 billion years. Raise your hand for true. Okay, raise your hand for false. Okay, almost dead on 50-50 on that one. The answer is true. Okay, Neil and Buzz actually put an experiment on the moon called a retroreflector that universities around the world can send a light beam there. That light beam comes back in 2.6 seconds. They can measure the exact distance to the moon. And guess what? It's moving away from us about an inch every year. Sorry? No, but it's going to get farther and further away. But guess what? At a certain point, it loses that orbit. At that point, when it's so far away, it'll float out into the universe. Okay, and I don't know what the calculation is, but it's a certain distance that Earth's pull is no longer strong enough versus everything else that is going to be tugging at it. Good question. Okay, question 2. If you go to Australia, the moon will appear upside down compared to our view from Europe, Canada, USA. Raise your hand for true. Raise your hand for false. Okay, I got 80% false there. Of course it's true. They didn't come early enough to see that video. Yes, because we're here and the moon looks like this orientation, but that darn person in Australia, they're looking at that same moon upside down. So the craters that we see at the top, to them, those craters are up here on the bottom. So that orientation of the craters might look different on this cruise compared to the way you see those craters back in your home country, depending on what your latitude is. Question number 3, don't forget to keep score. The moon makes its own light like the sun does. Raise your hand for true. Come on, one hand. False. Okay, 99% false. Yes, that is false. Of course, it's just the light reflected from the sun to the moon and back over to Earth. Question 4, the same side of the moon is always dark. Raise your hand for true. Okay, 80% true, I think. False. Yeah, of course that's false. You guys got tricked by Pink Floyd's album. I knew it. There is no dark side of the moon. It gets different sides because that when you look up and you see just a crescent, okay, the other side is dark and et cetera, et cetera. So all sides of the moon get light at different times. Question 5, the Earth has always had just one moon. Raise your hand for true. False. Okay, 90% false. That is false because every now and then a little mini moon will come along, start orbiting Earth for a couple of years, and if it's not a stable enough orbit, it will just float on away. And you get these beautiful images of this setting moon here, or rising moon, whatever it is, in antique Greece. And it's interesting because when the moon is really close to the horizon there, I have a question for you. When the moon passes close to the horizon, it's bigger because it's closer to us. Raise your hand for true. 10% false. Yes, okay, most of you got that one. Yes, of course that's false because it's the moon illusion, which you may have heard about. When the moon is close to buildings and different things like that, your mind plays tricks on you and makes you think, oh, it's about 50% bigger than it normally is, but it's not. It's just your eyes playing trick. When that same moon is directly above, it's just going to look smaller to your eye. Apparently, there is a fix to the moon illusion. Anyone know what it is? Okay, apparently, if you see a moon on the horizon there and you want to get rid of the moon illusion, all you have to do is spread your legs like this, look at the moon upside down, and when you look at it upside down, apparently it looks back to normal size again. Try it out at home. Okay, let's get to the truth now. In reality, the moon is orbiting around the Earth, so it is always the same apparent size from our point of view. Raise your hand for true. Raise your hand for false. Okay, mostly false is there. You got the right answer. Because guess what? The moon has an elliptical orbit around the Earth. Sometimes it's a little closer to us, and sometimes it is a little further away. So you can see the size differences here. 12% smaller when it's furthest away. And guess what? When it's at perigee, the closest point to us, it's about 25% brighter. And you'll hear on the news them saying, oh, we got a supermoon tonight. That's what they're talking about, is the moon is at its closer point. And in fact, this is actually something called the lunar librations. This is actually a 1-month view of the moon. It's kind of jiggling a bit, like one side is always facing towards us, but it does have a little bit of a jiggle left to right and top to bottom. So in fact, we can see about 59% of the moon's surface, depending on where it is in that jiggle above in the sky. Beautiful, award-winning man on the moon in Spain, little photographer there, right on the top of the mountain. Then there's something called moon glow. You know, when you have a crescent moon, all you can see is the crescent. You can't see anything else, right? But when the clouds are right on Earth and the light's reflecting off of Earth to the moon, you can actually see the dark side of the moon too, in something called moon glow. Okay, question number 8. You're still keeping score. Which of these moons is the correct distance from the Earth Is it A, B, C, or D? These sizes are all to scale, but we have to figure out what the correct distance is. Let's have a show of hands for A, 5%, B, 5%, C, 20%, D, about another 50, 60%. Yeah, the answer is D. Distance to scale is D. In fact, the moon is about 30 Earth diameters away from us. Question number 9, how big is the moon compared to the sun? Take your pick, which of these? And the sun was so big here we couldn't fit it on the screen, so you got to picture it filling up the whole stage beyond the edge of the building there. Raise your hand for A. Okay, 80% there. B, C, a few hands, and D. Okay, the answer is A. You can fit a lot of moons in the sun. Question number 10, how big is the moon compared to Earth? A, B, C, or D? Let's see what you got on this one. Raise your hand for A. Okay, lots of hands there. B, lots of hands there. C, okay, and D. Okay, almost split evenly between those 4 answers. The answer is C. Okay, yeah, you can fit about 4 moons across the Earth's surface. Not quite 4 of them. And that is it for MoonQuest. Please tally up your scores and see who the smartest one in the family was, really. All right. Should I embarrass someone? Did anyone get 10 out of 10? Anyone get 9? All right, we got a 9 up here. Any other 9s? How about a hand for our 9 out of 10? Okay, let's talk about eclipses because we got some eclipses coming up. You guys have to learn all about these things. What's a lunar eclipse? Well, you can see in this particular case, it is where the moon is orbiting around the backside. We got the sun there, the Earth's shadow is coming across there, and the moon is literally just going through that shadow. And so Sunday night, starting at 10:50 at night, it's going to pass in the shadow, but not completely in the umbra. Part of it will be in the penumbra, so we're not quite getting a total eclipse. Oh, this gorgeous picture from Nairobi, Kenya, of a near total lunar eclipse. This is roughly the amount you'll see on Sunday night. It peaks at 1 in the morning on Monday morning, so if you're up. You probably won't see it quite as reddish. You typically don't get a blood moon unless 100% of it is covered. So keep your eye on any tinges of red that you might spot. Total solar eclipses, of course, is when the moon passes right in front of the sun. And when it does, you get a beautiful view like this. On April 8th, look for the sun's corona, because once it's totally hidden, you all of a sudden start seeing the corona, which you would not normally see on a regular day. The other thing to look for is things called solar prominences and solar flares and stuff like that. And those things will just appear kind of like a little pink spot kind of on any side of the sun. Now, in this case, would it look like this if the moon was at its farthest point from us? No, because it wouldn't be able to cover the whole sun, but it's a little closer and it's able to cover the whole sun. If it's not big enough, you see in this animation here, the moon goes in front of the sun, but there's still a ring around it, so that's called a ring of fire eclipse. We're not getting this on April 8th. We're getting a total eclipse, so it's going to go totally dark for 4.5 minutes. And then you get these beautiful things called a transit. Can anyone spot Venus in that transit there? Okay. Yeah, there it is right there. Get a good look at it because the next one's not happening for about 90 years. And then you get these things called lunar occultations. This is a time-lapse video of the moon. And sometimes the moon plays hide and seek with the planets. And sometimes it will hide like even 2 or 3 of them all at once. So let's take a look at this time-lapse video. Just yell out the name of whatever world it is playing hide and seek with. Let's take a look. Yay, we got Saturn just peeking out from behind the moon. And remember, in a few months, those rings will be edge on with us, so you won't even see Saturn's rings for a few months until it tilts the other way, and then we'll see the rings again. Great shot. But I would really love to actually go to the moon, so I'm going to have to ask for the help of Hollywood to see if we can visit the moon. Here we go.
I would like to leave this city. This old town don't smell too pretty, and I can feel the warning signs running around my mind. And when I leave this planet, you know I'd stay, but I just can't stand it. And I can feel the warning signs running around my mind. So here I go, I'm still scratching around in the same old hole. My body feels young, but my mind is very old. So what do you say? You can't give me the dreams that are mine anyway. You're half the world away. You're half the world away. You're half the world away. I've been lost, I've been found, but I don't feel down. You're half the world away. I've been lost, I've been found, but I don't feel down. I don't feel down.
I don't know why I cry every time I see that. All right. Okay, we've got some amazing astrophotographers in the world. These astrophotographers here, Andrew McCarthy, merged 250,000 images together so you could get a better look, okay? And if you look at this merged image here of the moon, you see something called the terminator line, which is right where the light and the dark point. Can you see how many more craters are right along the terminator line, and there's hardly any craters over on that side? Okay, of course, that's just an optical illusion. There's as many craters over here as over here. It's just that the angle of the sun that's hitting the craters on the terminator line is causing those shadows to appear, so they look more intense. And Andrew McCarthy did the very same thing. He said, I'm going to give you an all-terminator view of the moon. If you could have the shadows on all of the moons, on all of the craters on the moon, he merged thousands of pictures together to give you an actual view of what it would look like, the all-terminator view of the moon. Moving on to nebulas. I got to go fast for this part because I have so many pictures to show you. What is a nebula? It's a bunch of clouds of dust and gas, the remnants of a supernova explosion. This is the Crab Nebula that Chinese and Arab astronomers spotted in 1052, almost 1,000 years ago, when the supernova exploded. The Ring Nebula, the Veil Nebula, nicknamed the Witch's Broom Nebula. How about the ghosts of the Cepheids flare? Can you see the ghosts? Yeah, kind of jumping out of the cloud there. The Eskimo Nebula. And these are formed, some of them are supernova explosion, but some of them are called something called planetary nebulas, where it's not big enough to explode. Like our sun is not going to explode when it runs out of fuel in 4.5 billion years. It's going to just release its outer layers like this, and it's going to end up with a white dwarf star in the middle, about the size of a city. So it's going to go from 1 million miles to this small white dwarf star in the end, billions of years from now. Or the Elephant's Trunk Nebula. In our fastest spaceship would take you 35,000 years to get from one end to another. Are you ready to play a game and name that nebula? We got to do this fast, so yell out the name of these nebulas because astronomers love to name things based on what they look like. Okay, so let's see if you can name that nebula. Go ahead. Yeah, Butterfly Nebula, or also sometimes called the Bug Nebula. How about this one? Yeah, Horsehead Nebula. Heart Nebula, you got it. You're not, oh, this one is the Helix Nebula, Eye of God. Also a planetary nebula with a white dwarf in the middle there that you can see right in the middle. How about this one? No one got this one? I'll give you a hint. Okay. Yeah, the Cat's Eye Nebula. How about this one? Can you see his legs here, his tail, his head? What's this one called? Okay, astronomers are more creative than you. They call this one the Flaming Creature Nebula. How about this one? You need a hint? Yeah, the Jellyfish Nebula. How about this one? Hint? Yeah, Thor's Helmet Nebula. This one's a tough one. You get a bonus point if you can get this one. Anyone? Seashell? No. How about a hint? Yeah, the Manatee Nebula. Oh, how did that one get in there? Sorry about that. We'll talk about that one later over a beer. How about this one? Okay, the Pelican Nebula. Angel. A lot of you said angel. Yeah. Flying Angel star-forming region. How about this one in the middle? What's that? Jelly bean. No, a jelly bean's oblong. This is perfectly round. The Diamond Ring Nebula. This is a simple name. That's the only hint I'm giving you. Okay, the Red Bubble Nebula. And this is just an animation, but this thing is literally flying out at 3,000 miles per second. So it looks pretty calm here, but in reality, you don't want to get in its path. How about this one? Yeah, a lot of you got that one. That's the Dolphin Head Nebula. And how about this image here? This is a composite of many different wavelengths of light, and it's going back and forth between the different images. What do you want to call this one? You don't need the hint on this one, right? Of course, this is called the Christmas Tree Cluster. We're going to zoom into the Eagle Nebula. I need you to yell out the name of the object that it's going to zoom in on. As soon as you recognize it, yell out the name. What's that? Anyone? Those, you got it in the back there, pillars of creation, because they look like there's these great big pillars, because this is a star-forming region, and what scientists discovered here is these nodules called evaporating gas globules, where as soon as the temperature heats up to 18 million degrees, a star is born, because nuclear fusion happens at that temperature. So each of those little nodules there is where a new star is going to form. Let's end with the thought of light pollution that we have. And this is different gradients of light you're going to get depending on where you live. So if you get a totally dark sky, the Milky Way is going to look like that. But the closer and closer you get to the city, many of you, about 90% in all of America, United States, and Europe, don't get to see the stars anymore at all. So let's give the last word to a couple of filmmakers by the name of Gavin and Haroon, Canadian and a Bosnian American, who are really upset about this light pollution and wanted to bring the real view of the night skies to you. Let's take a look.
That we used to do is get around the campfire every night and talk about different subjects, and stars were almost always the most important one.
What we found is when you're shooting this stuff at 25 to 30 second exposures on your camera, it's letting in so much light that even if a city is 100 miles in the distance, it can blow out the stars and it can take away the Milky Way and all those things that we're out there trying to capture. What we wanted to accomplish with this time lapse was to sort of ask people what if, and to show them essentially what if.
All right. And your final thought of the day from Oscar Wilde, Irish poet. Okay, we are all in the gutter, but some of us are looking at the stars. So I hope you can join us for stargazing Sunday night at 9 o'clock. We're going to talk about the eclipse and stuff like that. If you have telescope, binoculars, tripod, bring your app, which is your stargazing app. That'll help us out a lot. Download different apps out there like Sky Safari or Skyview. So those are a couple of good ones you might want to get your hands on. Don't forget to bring your cocktail or a Blue Moon beer. Okay. And the eclipse itself, Sunday night from 10:53 p.m. to 3:32 in the morning, peaking at 1 o'clock in the morning. That is it for Stunning View of Planet Earth. I'm out of time.